Hello viewers, you are welcome back to Lab Premium Consult. In today's video, we are going to take on to part 2 of correlation and regression analysis with a practical example. So as you can see on the screen, I'm about reading. A fire insurance company, into bracket, Ethan and J Insurance, wants to relate the amount of fire damage, into bracket Y, in a newly created regional capital to the distance between the residence and the nearest fire station X. A sample of 10 recent fires in these regions is selected. The table below summarizes the above information. So we have fire damage represented as what? Y in dollars. So these are amounts whenever the distance between the residence of the person and then the station is also given here, and then we have the amount of fire damage. So the requirement here is I. What is the correlation between the amount of fire damage and the distance to the nearest fire station? Use Pearson measure. Interpret your results. So we are asked to calculate correlation coefficient using what? Pearson method. Then II. From regression equation of the form y is equal to alpha plus beta multiply x, where y is the amount of fire damage and x is the distance to the nearest fire station. Estimate the constant, that is the alpha, and then the slope, that is the beta. Then III. Interpret the slope and then the constant estimated from II. Then IV. If Professor Eduche lives 40 kilometers from the nearest fire station, what is likely to be the amount of fire damage to his house should there be an incident of a fire at his residence in northeast region? Then V. The coefficient of what? Estimate the coefficient of determination, that's R square, interpret it. And lastly, list 4 properties of correlation coefficient. So this is a question that we have been given, and then we are asked to go through in that particular case. So we are asked to find the correlation coefficient using the Pearson measure, and then know the correlation between the amount of fire damage and the distance to the nearest fire station. So how do you then find correlation coefficient using Pearson measure? So it said that R should be equal to N multiplying what? Summation X, Y, bracket close, minus open bracket, summation X multiplying summation what? Y, bracket close, all divided by the square root of N into bracket summation X square, bracket close, minus open bracket summation X all squared, right? And then bracket close, and then bracket close, multiplying open bracket summation Y squared, right, minus summation Y all squared, and then bracket close. So this is how we use the Pearson measure of calculating correlation what? Coefficient. This is a formula actually. So you can clearly see that within the formula we have a number of elements inbuilt here. So we need to have a column called what? XY. We also need to have a column called X square. We also need to have a column for Y square. Is that okay? And also a column for what? Y, and then that of what? The X. So always, for you to know how to calculate a particular formula, you must find out what are the elements within that formula. That will help you to actually go by the approach. So that's what we're going to do in that particular case. So let's take our table. So we're going to pick our table right from here. So in our table, we're going to have a column for what? X, and a column for what? Y, right? That is always given in the question. So we're going to pick these values for X and then that of what? Y. So we're going to state it down. So we're going to have here to be X, and then you have your Y to be here in that particular case. So this is the column for that of what? X, and that of Y. These values was picked from the question that was given here. right? So these are the values. So let's sum them up and let's see the total for summation x and that of summation what y. So with summation x, after summation you should be able to get a total of 144, and that of summation y you should be able to arrive at a total of what 530. So that is for summation x and that is for summation what y. You can clearly see that with the formula we had what summation x here, and we have what summation y here. That's for field, but we also have what summation xy, right? So we are going to look out for summation xy, and from there move on summation x square, and then move on summation what y square, so that we can easily get our formula done in that particular case. So we're going to have a section called summation, or a column called summation xy. So meaning is xy. After when you sum them up, we get a summation xy. So xy here, what we mean here is that is to multiply what the values of x by the values of y in that row form. So 20 by 80, 15 by 60, 12 by 40 until you exhaust what the list. So that's what we mean by what x multiplying what y. So that is what we need to know. So these are also the values for what x and what y. When you multiply what individual values of x and y, you get these values. 1600 runs down up to the last value, which is what 2250. So this one you also have what summation for a total of what x and y. So that's going to be what summation x y. So after summing them up, you should be able to arrive at a total of what 10,120. So that is for column what xy. So back to our formula again, we also have a column or a section where we have what we call x square. So we're going to have what a column called what x square, and then lastly move on to what the y square in that case. So let's take note of that. So you will have a column called what x what square. So here fortunately we have the values of what x here, so it's a matter of what squaring individual values within the x what column or s domain. So here when you take the 20 you square it, when you take 15 you square it in that order till you exhaust what the list. So when you take what 20 square, you should be able to get what 400, okay, in that order. So after squaring all the individual values in the x domain, you should be able to arrive at what these values: 400, 225, 144, 64, 256, 36, 900, 400, and then 625. So here too, you also need to find the summation of what x square value. So that's going to be summation x square, and after summing them up, you should be able to arrive at a figure of 2,754. 2,754. So after getting your values for x square, you also move on to the values of what y square. So we're gonna have what a column for what y square. So y square, fortunately we also have what the values of what y being given here. So in that too, you are going to fill the values of what y. You are going to fill the values of y by squaring what individual values within y what domain or y what range. So when you take 80 you square it, when you take 60 you square it until you exhaust what the list. So let's take note of that. So for the first 80 you can arrive at a figure of what 6,400 in that order. So after squaring the individual y values here, these should be the values that you should obtain for those values in here. So once you are done, you should be able to sum them up. Okay, so we're gonna have summation y square to be equal to, after summing them up, you should be able to arrive at a figure of 37,850. 37,850. So after getting all the parameters within the coefficient of correlation formula, that's the Pearson measure formula, the next step is you're asked to calculate what the correlation coefficient using the Pearson measure. So that's going to be I. So you're gonna have our I here, where R is equal to what the whole of what this formula. So let's do so here. When you get to this stage, it's a matter of substitution after getting your parameters within this formula. So now we have what? N in this case was what? 10. So let's see. 1 2 3 4 5 6 7 8 9 10. So n is what? 10. So you tell us that r should be equal to, so on the numerator we have what? 10 into bracket summation xy. In this question was what? 10,120. We're gonna have 10,120. Okay, minus, have your bracket open, we have what? Summation x. Summation x in this case was what? 144, and summation y was what? 530. So you have here to be 144 multiplying what? 530, then bracket close. So that's for the numerator. And you come to the denominator. So the denominator 2 here is the square root of these parameters. So within the denominator we have what? N. So n is what? 10. So we're gonna have here to be what? 10 into bracket. We know for summation x square in this particular case was what? 2,754, right? So let's see. So we're gonna have here to be 2,754. Okay, minus summation x. Summation x was what? In this case, summation x was what? 144, right? So let's pick that from there. So it's going to be what? 144 all what? Squared, and then bracket closed, multiplying, then come back to the same thing for with that. Once we are done for the x, we also do same for what? That of what? Y. So that's going to be open bracket 10, and then we look out for what? Summation y square. Summation y square in this particular case was what? 37,850. So we're gonna bring it here. 37,850. Okay, minus, then you follow suit, and then that of summation what? Y2. We're told that summation y2 is what? 530 per our calculation. So that's going to be what? 530 all squared, and it goes the bracket, the main bracket. All right, point this whole expression on your calculator. You should be able to arrive at 0.9654. In 4 decimal, you should be able to arrive at what? This what? Value. All right, it is 0.9654. Okay, let me add 1 to it, so making it, let's say, 8. So if I want to run it to, let's say, 4 decimal place, I can say that r should be equal to 0.9655. So this should give me my correlation coefficient. So 0.9655 tells us that there is a strong positive relationship between the values of x and then the values of y. In this case, the distance between what? A nearest residence and to a fire station, and the fire damage with respect to what? The amount. So there exists what? A strong what? Positive what? Relationship or correlation between the values of x and the values of what? Y. So that is the interpretation behind this formula. So this is a strong positive correlation, meaning that in terms of their relation, there exists a strong positive what? Correlation or relationship between these what? Two what? Variables we are talking about here. I hope that is clear. So that is that with the I part of this question. So we were asked to from the regression equation of the form y is equal to alpha plus beta x, where y is the amount of damage and x the distance to the nearest fire station, we are asked to estimate that of the constant and then the slope. So with that, we know to find what? Your constant of our regression equation is equal to what? Alpha plus beta multiplying what? X. We know that alpha is equal to y minus beta multiplying what? X bar, right? So we have what? Y bar and then X bar here. So mean that we need to have what? These values also down. But before we can find what? The alpha, we need to know the beta, which is what? The slope of what? The regression equation, for which we know the formula is what? Summation x y minus n into bracket y bar then x bar bracket close, all divided by summation x square minus n into bracket x bar or what? Square. So this is the formula for finding what? The slope of what? The regression equation. All right, so we need to find the slope before we come to finding the constant. All right, so let's see how we find the slope. But because we have y bar and then x bar, we need to go back to our table so that we calculate for the value for y bar and that of what? X bar, so that we can easily fit. But the rest of the elements here is already in our table, so we can take them right away from there. So going back to the table, we already have what? Summation s, we already have what? Summation y. So for me to find that of what? My x bar is going to give me what? Summation x all divided by n. Then same for y, is going to give me summation y divided by what? N. So let's go. So we have summation x was what? 144, right? Divided by what? N is what? 10, right? And then we have that of y2 to be equal to 530 and then divided by 10. So in this particular case, we can say that x bar is equal to 14.4, all right, and then y bar is equal to 53. So this becomes what? The mean of x and then the mean of what? Y. So let's take note of that. So once you have gotten those values, then we can easily calculate our beta in this particular case. So therefore, our beta, which is the slope of the regression equation, is going to give us, so we know that of summation xy from here, summation xy from here was what? 10,120, right? So you can pick that figure right from here. So we can see that here is going to give me 10,120 minus, we know n to be what? 10, so we have 10 here, but we know y bar to be what? 53, and we know x bar to be equal to what? 14.4 bracket close. So that is for the numerator. So we come back to the denominator. So we have x squared from our table. We have x squared to be equal to what? X squared to be equal to 2,754. So we bring that one also here. 2,754 minus, and we also know n to be 10. We also know that of x bar to be equal to what? 14.4, and then we squared it. We squared it in that particular case. So therefore, we can say that the slope of this equation here is a matter of using your calculator. It's a matter of using your calculator. Don't waste time here. So here, by my calculation, I had the slope of the regression equation to be equal to 3.6567. That's in 4 decimal places. You should be able to arrive at 3.6567. So that becomes what? The value of my slope, which is being represented as what? The beta. All right. So once you have gotten that, therefore, we can continue to find that of what? The constant or the y-intercept of the regression equation, which is equal to, well, which we know is what? Y bar minus beta, which is the slope, multiplying what? X bar. Is that okay? So in this case, we can say that y bar in the question was what? 53, right? Minus, we know beta has been calculated as what? 3.6567, and then multiplied by our x bar to be equal to what? 14.4. So with this, it's also a matter of you using your calculator, right? You should be able to arrive at a figure of what? 0.3439. In 4 decimal place, you should be able to arrive at 0.3439. So let's take note of that. So the next question here is, we are asked to interpret the slope and then the constant estimated from II. So this is what option, or that is II that we are dealing with. So let's move on to II. We are asked to interpret the slope and then the constant. So let's see how the interpretation goes. So you can clearly see that, therefore we can say that our regression equation is going to be the constant of 0.3439 plus our slope, which is equal to what, 3.6567 multiplying what, x. So this becomes what, our regression equation. So this primarily tells us that the slope, the constant, let's start from the constant for which you know is what, the y-intercept. By y-intercept we mean that when we substitute what, x to be equal to 0, that should fetch us what, the value of y. That's why we call it what, y-intercept, or with the constant is also called the y-intercept. So 0.3439 is the constant, or the y-intercept is the value at which the fire station in kilometers is what, 0. So this is what I was talking about. So where we have what, x to be amounted to 0, then we can say that the constant is equal to what, the y. So that is the interpretation behind. So it is a value at which the fire station in terms of distance is equal to what, 0. From the residence to the nearest fire station is 0. So that is the interpretation behind. And when it comes to that of the slope, which is what, 3.6567, it is actually the gradient of what, this regression equation. And this 3.6567 represents the slope of the equation. We are saying that this is the value which increases, please take note of this, this is the value which increases or decreases the amount of what, fire damage, which means as what, y, whenever the distance between the residence what, place and that of fire station changes. So this is why we are saying that this is the value which increases or decreases the amount of fire damage whenever the distance between a residence and the nearest fire station is what, changes. So let me give you an example, typical example from here. So let's say we have a distance between a residence and fire station to be called, let's say we have 8 here and we have, let's say, 2. All things being equal, when I substituted the value of 8 in place of this x, whatever I'll get from this equation, the result I will derive is going to be different from whenever I substitute what, 2 there, right? So that's what we are talking about, that it is the value that increases or decreases the amount of fire damage whenever the value of what, x, in this case the distance between a residence area and that of what, fire station, what, changes. So when it changes from 2 to 8, it also changes the whole amount they're going to derive at the end of the day. So that is what we call the slope of what, the equation. This is the interpretation behind in that particular case. So let's take note of that. Now let's move on to IV. We're told that if Professor Educhi lives 40 kilometers from the nearest fire station, what is likely to be the amount of what, fire damage to his house should there be an incidence of fire at his residence in northeast region. So here is a matter of quoting the formula, which is equal to 0.3439 plus 3.6567. I hope that is right. Yes, 6567 multiplying x. So here we know at x to be equal to what? At x to be equal to what? 40 what? Kilometers. What is going to be the value of y? So the value of y is going to give us what? 0.3439 plus 3.6567, and then substitute whenever you see x, substitute what? 40 there. So at the end of the day, per your calculation, you should be able to arrive at a total of because we are dealing with what in Dallas and in 3 zeros, at the end of the day, you should be able to arrive at a total of what? 146, right? 146,611, all right, 0.90. So this is going to be the amount of fire damage that will cause when Professor Edochie leaves a distance from his residence to the fire station, 40 kilometers. This is the amount of fire damage that it will cost him for the fire service personnel to come and rescue him or her, right? So that is what we are actually talking about. That's what we are talking about in this particular case. So let's take note of that, and then let's move on to that of V. We are asked to, let me have the V here. We are asked to estimate the coefficient of what? Determination, that is R square, and interpret it. So we know for coefficient of determination is basically your R square, right? And then multiply by what? 100%. Then multiply by 100, which is 100% in that case. So we know from our coefficient of correlation, we had a total of what? Or a figure of what? 0.9. Let's see. It was 0.9655. 0.9655. So 0.9655 all squared, and then multiply by what? 100. Here, don't worry yourself, just use your calculator and we are good to go. So at the end of the day, you should be able to arrive at a figure of 93.22% in 2 decimal place. You should be able to arrive at 93.22%. So this 93.22% actually is the coefficient of determination, which tells us that there is a high proportion of variability in the variable what? X. In the variable X, that is the distance between a residence and the fire station, that can influence the variable Y significantly. Hence, the longer the distance causes high amount of what? Fire damage, and vice versa. This is what we mean. You see, with our correlation coefficient, we're having a strong relation between that of the distance and that of what? The amount of fire damage. So the coefficient of determination tells us a proportion of variability in one variable that can influence what? Another what? Variable. But here, note, we are not talking about causation here, so you need to get the things right here. So here, this 93.22% actually tells us what? How much variability that exists in what? That of what? The distance or variable X that can influence what? Variable Y. Should, in case there is high distance from a residence place to the nearest fire station, that can cause high amount of what? Fire damage to that particular what? Residence, in terms of what? Rescue. So we can even use an example of Professor Edochie's own here, where he was having what? The distance between her residence or his residence and that of fire station was 40. You can clearly see this is the amount that it cost him or her to rescue him or herself. You see, so the higher the distance from your residence to the fire station, the more it costs you to actually rescue yourself in terms of amount. But the lower it is, the lesser you pay for in terms of fire damage in this particular case. So that is what coefficient of determination actually tells us. It tells us the variability of one variable that can influence or affect another variable. Is that okay? So that is what it's saying. So here you can clearly see there's a high proportion of variability in variable X that can influences the amount of fire damage that can cause a person, should in case his place to the fire station is quite long or longer. So let's take note of that. So that is that of the V. And then the VI, we are asked to list 4 properties of correlation coefficient. So the 4 properties of correlation coefficient, I'm going to give you just offhand, then we are good to go. One is, always, you know that when it comes to correlation coefficient, you know that it always ranges from what? -1 to +1. That one is a must. So that's one property of a correlation coefficient. So that is one. Two is that the coefficient of correlation measures only linear correlation between two variables, say variable x and what? Y. Aside, that doesn't measure any variable that is above what? 2. So minimum and the ceiling is what? 2 variables, say x and y, say p and what? Q, say a and what? B. All right, so that is what correlation coefficient actually deals with. It measures only linear correlation between two variables alone. So let's take note of that. And 3, if two variables, say a and what? B, right, are independent, one of the properties of correlation coefficient is saying that if two variables, say a and b, are independent, then the coefficient of correlation between them will be what? 0. Because correlation coefficient tells us what? A relationship that exists between what? Two variables. But if there is no relationship, there's nothing common between a and b, then we can't find the correlation coefficient, and as such the correlation coefficient between the two is going to be what? 0, because the variable a and b are what? Independent of each other, and as such the correlation between them is going to result to what? 0. So that's what we are talking about here. And lastly, the coefficients of correlation are independent of change of what? Origin. Are also independent of what? Change of origin. And other things that we can also, it has a lot of properties. You can also search around to get more as well. So these are the few tips I want to share with you. So actually, this is where we bring an end to our discussion on correlation and regression analysis question discussion. So if you have any question, please drop it in the comment section. And if it was really helpful to you, please go ahead to like this video, subscribe to the channel, and then share and recommend to all friends and any students or any person who is interested in this kind of tutorials and to help them. So I'll see you next video. Bye bye.